Do you ever wonder if you're a noob programmer, constantly wondering why your code doesn't look as good or clean as the code you see online? Well, in this video, I'm going to compare noob code to professional and advanced code and show you how you can go from this noob code all the way to the more advanced professional code, and I'm going to do so through multiple examples. So you make sure you stick through each of the examples so you can see all of the different elements of transforming your code from noob code all the way to clean professional code. Let's get started now. Welcome back to Web Dev Simplified. My name's Kyle, and my job is to simplify the web for you so you can start building your dream project sooner. So if that sounds interesting, make sure you subscribe to the channel for more videos just like this one. Now to get started, I have two different examples that I'm going to use to break down this noob versus professional code. And the first example is just a basic example that's going to be going over how noob programmers handle logic and how professional programmers handle complex logic. And in the second example, we're going to look at a function with some variable manipulation, which exemplifies a lot of points inside of it, so it's going to be a pretty lengthy section. But to get started with, we're going to go over this basic logic section. So let's open up this noob version of the code, and essentially we just have a single function which is going to be taking a number. We're going to be passing it any number between negative infinity, positive infinity, it doesn't matter, and we want to convert this to an accounting string version of that number. So in accounting, when you have a negative number, you surround it by parentheses like this, so this would be negative 10 right here, while if you have a positive number, you just print it out like normal. So this right here is positive 10. So we have negative 10, positive 10, and all this function does is take in our number and convert the negative ones to have parentheses, and the positive ones do not have parentheses. And if we look down at the bottom here, I have a couple examples for how we can print out this code. So we're planning this with 0, 10, and negative 5. And if I just run this really simply right here, this logic noob version with node, you can see that we get printed out 0, 10, and then this negative 5 is inside of parentheses. So that all works essentially like we want it to. But there's a few problems immediately when we look at this code. And the first thing that you notice with a lot of noob programmers is that they have kind of redundant if statements. For example, we're checking if n is less than 0. We do this code for putting parentheses. Otherwise, we're checking if n is greater than or equal to 0. And if n is not less than 0, then automatically it has to be greater than or equal to 0. So there's no point in having this if check here. So we can just completely remove this. We don't need this. So that's something that a lot of newer programmers are going to do, which you don't actually need. And if we save and rerun, we get the exact same results. Another issue that I see with a lot of newer programmers is that they don't take into account the type of the variable. As you can see here, we're returning a string that's surrounded by parentheses. But down here, we're just returning the number we got passed in, which is a number. That is why you see these yellow colored 0 and 10. That is because those are of type number, while this 5 here in the parentheses is a type of string. So this function is actually returning strings and numbers, when in reality, it should only ever return a string. So this should probably say n.toString instead. And now if we run this, you're going to notice everything being printed out is white, and that is because they're all of the string type, and no longer are we returning any numbers at all. Now the last thing that I want to take into account is that newer programmers a lot of times forget to think about null or undefined. They think about all of the good values that get passed into a function, but what happens when undefined gets passed into your function? If we run this, we're going to get an error. As you can see, we're getting this error n.toString cannot read property toString of undefined, and that's because this variable n is actually being undefined by this first variable function here, and then n.toString, obviously undefined has no toString function, so this is throwing an error. So that is a big problem I notice that a lot of newer programmers don't take into account. Also, they use pretty bad naming a lot of times. I mean, this n variable is very abstract. You don't really know what it is. Is it a number? Is it something else? I don't really know. So this n variable is not the greatest. And this toAccounting is also a little bit vague. It could be better explained exactly what this means. So let's jump into the advanced version of how a more advanced programmer would handle this. It's going to look very similar actually. As you can see here, we have better variable names. We have number to accounting string to make sure that we're saying that we're taking a number, converting it to a string in the accounting format. We're also using a variable called number here instead of n, just makes it easier to read the code. And lastly, we're checking here for null. So we're saying if number is not equal to null, then do everything, otherwise just return undefined. So now, If we were to change this to run our advanced version instead, you're going to see that this first one returns undefined when we pass an undefined, which means we no longer throw an error and we're actually properly handling getting undefined passed in. And then everything else returns exactly as before. Also, you're going to notice another slight difference here is that we have template strings instead of using concatenation. As you can see here, we're concatenating multiple strings, and here we're using the template literal syntax in order to write these strings in line together, which just makes for cleaner strings. And if you want to learn more in depth about these template literals, I have an entire blog post on them. I'll link down in the description below. But essentially, it just makes it easier to write strings with numbers or variables inside of them. Now this code is where probably most of you are when it comes to programming. You're going to write this code and not even think twice about it. And honestly, when I start writing code at first, and I'm writing out a function, this is a lot of times what my code looks like before I go back and change it and refactor it to make it look cleaner and better. Because this function works and it really doesn't look too terribly bad. So you would think, okay, this is good and I'm going to stop here. But a professional programmer would take this a step further to clean up this code even more. So let's look at the professional version. As you can see here, the code is quite a bit more condensed and a lot easier to read. We have the same good variable names of number to accounting string and number, but you'll notice the way that we handle all of our checks is much simpler. Our first check here, if number equals null, so essentially if we pass in undefined or null, we just return nothing. We essentially return undefined. And then if our number is less than 0, we just do that same string concatenation as before and make sure we return that. And then otherwise, if none of those cases are true, we just return the stringified version of our number because it's a positive number. And what this is referred to, where you have these if checks and you return after each one of them, this is called a guard clause. And I also have an entire blog post on guard clauses. I'll link down in the description for more in-depth information. But essentially what a guard clause does is it just says, if this condition is met, then return out of the function because we don't want to compute anything else. And the reason you use guard clauses is because we can have all of this if logic in one line. For example, we have no nesting. We don't have nesting like this if is inside of this if. It gets rid of all of the nesting that you would normally have if you did your if checks like this in this advanced version of this function. In here we have a lot of nesting, and nesting is really hard to read because you have to think, okay, if it's not equal to null and it's not less than 0, then we return. Otherwise, we back out and say, okay, if it's not equal to null, then we do this. So it's really hard to kind of wrap your head around complex nesting, which is why almost always you're going to see guard clauses used instead, because it's much easier to read a guard clause because it just says, if we're equal to null, just exit immediately. If it's less than 0, exit immediately. And you don't have to think further than that. It's just one step nesting, which is perfect. And to make sure that all of this works, let's just come down here and run this. So we can just say 3, run the pro version, and we get the exact same results, undefined 0, 10, and then the -5 inside the parentheses. So we know this function right here works exactly the same as this more newbie version or this advanced version. It's just much cleaner to read and much easier to write and much easier to maintain in the future, since if people need to change this, they don't have to worry about memorizing all of this complex nesting. So that is the main point of this logic section, is to show you how to use guard clauses to break out of that complex nesting, and also to make sure you think about variable naming, as well as think about how to handle null, undefined, or really any value that is unexpected being passed into your function. Now this next section that I want to talk about is going to be all about variable manipulation. So let's open up this Noob version. And what we're doing here is we're calculating the total. Essentially, we're passing in a list of items, which are going to have this price and this quan property, which stands for quantity. So essentially the cost of the item as well as how many we buy. And then we pass in some options, which is going to be either the discount that we applied, which is dis, or the shipping cost, which is ship. And we calculate what the final total price of all of these items with the discounts, with the shipping, with taxes, everything included is going to be. So that's what this calculate total function does. And already, just by looking at this, if I didn't explain that to you, you'd probably be a little confused by what this function does, just because the names are not quite as good as they could be. I mean, T is kind of self-explanatory that it's total, but you really have to know what the function means to know that this is total. Also, quan is a little bit confusing. Is this quantity or is this like something else? I'm not sure. Same with discount and shipping. They could just be a little bit more explanatory. Also, something that's really confusing here is what does this 1.1 mean? Is this The tax percentage is this some other value, I'm not really sure, so that's a little bit confusing. And also this 5 is a little confusing because what exactly is this? In this example, it's the default shipping, but it's hard to tell that just by looking at the code. So in order to clean this up, there's a lot of things that we could do. Namely, some of the biggest things are to increase our variable names and to break out some of these constants into their own variables so that way that they're easier to understand. Also, something that I see all the time that happens is a bug that a lot of people run into when they're newer in programming, and that's by having this OR syntax here, where we're saying options.shipping or 5. What happens is if the shipping cost is 0 OR is going to return false, which means this 5 is going to be returned instead. So if we pass in a shipping of 0, for example right here, we're going to be getting an actual shipping value of 5. And if I run this example by just saying node here, we want to run the Noob version, you're going to notice this first test that gets run here is going to be returning 82 as the total cost. And then our next test, which has a shipping of 0, so it should be $5 cheaper, still returns the exact same value. And that's because we have this OR here, and 0 OR is always going to return what's on the other side of the OR. So that's something really important to take into account when you're writing out code like this, is to make sure that you don't have bugs with that OR when you have like a 0 or an empty string or something like that, which could evaluate the value on the other end of this OR. This is something I see all the time from beginner programmers. Also, we have our discount being applied properly, 75% off, and then our shipping here, we added $7, I'm sorry. So this 82 gets to 89, which is $7 more. So all of that is working. But there's quite a few problems. If, for example, we pass nothing into our function, it's obviously going to error out because items is going to be null, and you can't call for each on something that's null. And then another problem that's really big is, and what happens if we want to pass no options? As you can see down here, we're passing an empty option list. So normally you just don't want to add that to the function. So if we do that and run this, we're going to get an error, as you can see, because we're always trying to access our options, for example, and there's no default value for our options. Kind of a similar thing with down here, if we pass undefined for our list, we're going to get an error. And kind of a hidden bug is if we pass no items, as you can see right here, and we run this, you're going to notice that we get a total cost of 5. Even though in reality, if there is no items, you shouldn't have to pay for shipping. So there's quite a few bugs baked into this code, as well as the fact that it's really hard to read. So let's jump over to the advanced version where we fix a lot of those bugs and also make the code much easier to read. So over here in the advanced section, immediately the first thing you'll notice is we broke out these constant variables and gave them actual names. So our tax rate is named tax rate, our default shipping is called shipping default, so that way we have those broken out and we can actually handle those scenarios. Also, we handle the case of if our items are null or if we have no items by immediately returning 0. Because if you have no items, obviously you don't have to pay anything, there's no shipping cost, it's just going to return 0. So we handle that edge case properly inside of our calculate total, and we're even using a guard clause to do that, which is exactly what we want to do. Another thing you'll notice is our variable names are much better. We have total, we have price, quantity, discount. It's just much easier to read what each one of our variables is doing, which is really good. And also, we're passing in a default value for our options. If you remember over here, when we tried to call this with test items and no actual options afterwards, we ran into an error. But now inside of here, since we have a default value for our options of an empty object, we can actually run this code with this test items of nothing. And if I just do that real quick, you'll notice we get no errors. As you can see, it just prints out everything just fine. Actually, let me save. And there we go. As you can see, it's printing out that 82 value, even when we pass in no options, because it just defaults to this empty object. Also, something else you'll notice is if we scroll down here, I'll just comment this out and rerun this. You'll notice this price here is 82, as you can see by our first line. And when we have 0 for shipping, we're getting 77. So our shipping is properly being calculated if it is 0. And in order to do that, we just have a simple if check that says if our shipping is not equal to 0, then calculate shipping. Otherwise, if the shipping is 0, just ignore the shipping step. So that's how we're getting around that check with OR down here, which is a really clever way to do this solution. And overall, this code looks very similar to this Noob version. Really the only differences are we have much better variable names, and we also have a few extra bugs being fixed by checking for these edge cases, as well as having optional values here, and lastly, having these different checks for our shipping. So overall, the difference between the Noob version and the advanced version is very small. It's pretty easy to make these changes. So when you're programming, make sure that you think about the edge cases, for example, this situation, as well as these default values, and think about any potential bugs that could come up by thoroughly testing your application with all of these different edge cases. That's why I have all of these different tests down here, because that way I wanted to test everything thoroughly to make sure it worked in all regards. Now there are going to be quite a lot of differences between this advanced version and the professional version, but one thing to notice though is that when you're writing code, most likely the code you write is going to be somewhere between the advanced version and the Noob version. The first time you write code, it's never going to be professional and clean and perfect. It's going to be somewhere in between these two states. The important thing is that once you write that code that's in this advanced or Noob state, that you take that code and then transform it into a more professional looking code, because now you know what the code is supposed to do and you know about how it's supposed to look. That's actually how I wrote these examples. I started with this advanced version, for example, and then to make the professional version, I just edited the advanced version. There's no way my mind works well enough to think like the professional version from the start. Most people cannot do that. So now let's look at the actual advanced version. As you'll notice immediately, the code is quite a bit more condensed. There's a lot less lines of code inside of our function, which is not always a good thing, but it does mean that there's less to think about when you read the code, so it may mean that the code is cleaner overall. Also, we have the very same, constants here for our tax rate and shipping default, but something you'll notice is we are taking advantage of something called destructuring inside of the function arguments. And I have an entire video on destructuring. I'll link in the cards and description if you want to check it out. But essentially what we're doing is we're just defining the values for our options. For example, we have shipping and we have our discount. These are the only two things our options can ever be. And we're also setting a default. So if they don't pass in a shipping, we pass in a shipping default. So we don't have to worry about this if check or anything. We just know if there's no shipping passed in, we use the default. Same thing for our discount. If they don't pass a discount, we just default the discount to 0 because obviously you're not going to have a discount in that example. And then lastly, an important thing to notice about destructuring, we make sure we set this to an empty object here by default so that this entire options, which is what this used to be called, is made sure it's set to a default object just in case they don't pass anything in. For example, right here, they don't pass any options. We just want to make sure that we have an empty object as the default that we use instead of using null. So now with that out of the way, let's look at the rest of the code here. We have the same exact if check, which is great. And down here, we have a little bit of a different code for calculating out the total item cost. Over here, what we did is we looped through all of our items and added it to this total variable. But in the pro version, instead what we're doing is we're actually using this reduce function, which allows us to take an array and reduce it down to one single value essentially. And this value is called our total. So each time that we loop through our items array, we're given this total variable, and then whatever we return from here is being our new total. So we start with a total of 0, and then we're just adding to our total the price times the quantity. This does the exact same thing as the for loop. It's just a little bit tidier and cleaner way of writing it. And if you want to learn more about this reduce function, I have an entire video on that as well. I'll link it in the cards and description down below. Now the next thing to notice that is much different than the previous examples, as you can see here, we have one total variable and we just constantly update it throughout our entire function. But over here, we don't actually have a total variable. We have the cost of all of the items, and then we calculate our discount rate, and then we're just down here returning everything combined together on one single line. And what's nice about this is that we don't have this intermediate variable that's constantly being updated, because this variable total, you have to constantly keep track of every single line that modifies total to figure out what the new total value is going to be at that point in the code. And this is something that doesn't sound difficult to do, but in reality, it takes a lot of brain power to keep track of all of the different changes to this total variable as you go through the code, especially as you get longer and longer functions, and you have to go further and further with remembering everything that happened before. The nice thing about this version is we don't have any variables that get modified. This is all constants. So this item cost never changes after we define it. Discount rate never changes. So now we know as we go forward, this function could be 1,000 lines long, and item cost is always going to be the same. We don't have to worry about figuring out where we are in the function to know what the value is. That's a really important reason for using constant variables as much as you can and trying not to create these intermediate variables, for example, of total, where we just constantly update it and update it. This is something that I noticed a lot of beginner programmers do, and you're just adding extra work for yourself that you don't want to handle when you have to go back and change this code in the future. Really, other than that though, this final example does pretty much everything else exactly the same. We just took a lot of those intermediate calculations, put them on one single line, which is pretty easy to read. We just take the cost of all of our items, multiply it by our discount, multiply it by our taxes, and then add in our shipping at the end. And if I run this, just to make sure everything works the same as before, you can see we get all of the exact same values being returned to us, so we know that this version is working exactly the same as the previous version with all of the same inputs. So we went from this pretty complicated and difficult to understand function to a slightly easier to understand function, but it was still kind of long and bulky, all the way to this really clean, simple function that is actually pretty easy to read when you look at. It's much easier to figure out what this is doing than figuring out what this is doing, purely just based on variable names alone. I mean, just the difference between advanced and noob is almost exclusively variable name differences. And as you can see, this, while it looks more complex because it's more code, is actually way easier to read. And then obviously this version is even easier to read. And that's the important thing about programming. It's not about writing something that works. It's about writing something that's easy to read and easy to maintain. Because writing code is the easy part. I mean, anybody can write a function that looks like this, for example. This is easy to do. But changing this and modifying it in the future, that is the hard part, because now you need to memorize all this logic, or all of this logic. And that's hard, especially if you come back a year later. While this more advanced version with the better variable names and the cleaner, smaller, tighter code is much easier to read and figure out what's happening even a year or two in the future when you have to come back and change this. The thing to remember is that writing code is not the important part. The important part is writing code that's easy to read, since you're going to have to change it in the future. And there are all the differences that you'll see between beginner code and professional code. If you enjoyed this video and want to see more videos like this, make sure to let me know down in the comments below, because I had a ton of fun making this. And also check out some of my other videos linked over here, and subscribe to the channel for more videos just like this. Thank you very much for watching, and have a good day.